for this first question, you're already told that 20 kilograms is 2.2 pounds. You're told that fact by here. Now, strictly speaking, this is one of the facts that I think you should learn anyway. But if you were to use this fact to help you get there, if 20 kilograms is equal to 44 pounds, then I could halve both sides and say 10 kilograms is equal to 22 pounds. And I could divide both sides by 10 and get 1 kilogram is equal to 2.2 pounds. But I think you should know that one anyway, so if I were you, I'd learn that one. The next one says 10 litres of milk make 1 pound of cheese. Calculate how many litres of milk are needed to make 15 kilograms of cheese. Okay, so litres, that's fine, but pounds then into kilograms. So my thinking here is we need to get 10 litres. Well, we don't know how many litres are needed. We need to change this into kilograms and then change that to 15 kilograms altogether. So the first thing I'm going to write down is 10 litres is equal to 1 lb, 1 pound. I'm then going to go back to the fact that we've just worked out that 1 kilogram is 2.2 pounds. So I'm going to times both sides by 2.2. So that's going to give me 2.2 pounds lbs is equal to 22 litres. Now I'm going to rewrite that as still 22 litres, but I know that 2.2 pounds is 1 kilogram. Next, I am going to times both sides by 10 and get 220 litres is equal to 10 kilograms. I'm then going to halve each side, so 110 litres is equal to 5 kilograms. And then I'm going to add these two together, because 10 kilograms add 5 kilograms is 15, so I get 220 add 110 is 330 litres is equal to 15 kilograms. And because that's my final answer, I'm just going to put a bubble around it and make sure it stands out. Next it says, the label on the pack of the cheese also states that 100 grams gives that much blah 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 blah. Okay, so I need to try and work out a link between 100 grams and 1.5 kilograms. Now you should know already that kilograms means 1,000, so 1,000 grams is equal to 1 kilogram. So in terms of what we've got here, we've got 100 grams, and we want to change that to 1,500 grams. So what do I do to the 100 to turn it into that? And the answer is times by 15. Okay, number of different ways you can get there. I think that's, if you can spot it, it makes it a bit easier. 1 times the 15 makes 15 there, and then 2 zeros on the end, 2 zeros on the end is how I did it. So I'm supposed to be calculating the amount of protein. So I'm coming here, finding protein, 25 grams, that needs to be multiplied by 15. So I need to write down here, 25 multiplied by 15, which I've got absolutely no idea of. So I'm going to partition it to 25 times 10, 25 times 5, and I'm going to add those two solutions together. Not the only way I could do it. I could do grid method, I could do Chinese method. I might do Chinese method actually, and maybe it's a bit nicer than that one, because I sometimes confused myself when I was a bit younger with that method. So I'll set up the Chinese grid. You've got to be careful when you do this that you get true diagonals. If you don't, you'll mess it up. So must go through the corners like that. I mean, even mine could be argued that it's not that good. That should be going right through there and right through the centre. So you've got 25 here, and we're times them by 15 here. So when you times the numbers, let's do the 5 times 5 first. So 5 times 5, so this box here, would be 25. So you write the tens up here, units down here. So in this box here, 5 times 1 is just 5. So we just write the 5 down in the units, so that means you've got no 10. So I put a 0 up there. This would be 2, so 0 and 2. And this would be 10, so 1 and 0. And then you add in these diagonals here. Okay, if you need to carry, you just carry across the next column. So 5, 7, and 3. So my answer is 375 grams. And final bit, this one's quite easy, but only because of the question. It says, what percentage of the cheese is fat? So if we come up to the fat, look at it, we've got 34.4 out of What's the total value? Well, it's out of 100, so that makes this bit very easy. So out of 100, which is equal to 34.4%, because percent means out of 100. Okay, angles in parallel lines. Now we're quite lucky here that that's parallel to that, and then this is parallel to this, which is parallel to this. So that means we're going to get an awful lot of crossover of angles here. Anywhere that is an acute angle will also be this 35 that you can see. So I'm going to go and put in loads and loads of 35s straight away. So 35 there, 35 there. Look, I've already answered the first two questions. 35, 35, 35, 35, and 30. Oh, that's not 35, is it? This one here is 35. Okay, so I've already answered the x equals 35, y equals 35. Now to find the other angle, so to find the z angle here, I've got angles on a straight line, so all I need to do is do 180, subtract 35. Just be careful with this, 0 take away 5 is not 5, it's nothing, you can't do it. So I would take 1 from the 8, so we get 10 take away 5, which is 5, 7 take away 3, which is 4, and then 1 take away nothing, which is 1, so z equals 145. Okay, then question 3, the first thing I'm going to do before I even go any further is work out the scale. So here I've gone up by 0.1, and I've taken 5 little steps to do that, 1, 2, 3, 4, and 5. So I'm dividing that by 5. Now that's not the easiest calculation in the world to do in your head. Very, very easy to go wrong here. If you think of it as 0.10 divided by 5, you may find it a little bit easier. The answer is 0.02. Okay, and I'd recommend that you check by seeing if that makes sense. So we're on the 0 here, 0.02, 0.04, 0.06, 0.08, 0.10, 0.10 if you want to say that, but you shouldn't say that, strictly speaking, is 0.10. So yes, that is definitely correct. So I can tick that, and I know I've definitely worked out the scale. Okay, so let's plot these points then. Percentage cloud cover 55. Hopefully this one's reasonably obvious. Actually, I didn't go and work out the scale, but we've gone up to 10 in, not in 2, I've answered the question there. We've gone up to 10 in 5 little jumps, so each little one is worth 2. So 55 and 0.48. So I'm going to 55 first, so 50, 60, so 55 bang in the middle, 0.48. Now I'm actually going to go to 0.5 and come back 1. So I'm on here, and then I'm coming back 1 there. In the middle for 55, 0.48. And I'm going to tick it just so I know I've plotted it. 10 and 0.24. So here, and then I'm going up 2 from here. So 1, 2, there. 60 and 0.52. So again, 60, 0.5, and 0.52, just one little square up, so there. 85, so 85, so here, I'm going to come all the way up to 80, and then to 84 would be 2 little ones on, so in the middle there and there. And then 5 and 0.10, so 5, bang in the middle of 0 and 10, and then 0.10 there. Okay. Plotted, 2 marks, lovely 2 marks to get there. Just make sure you've done your scale work and it should be fine. The next thing we're going to do, describe the correlations. So they're only looking for one word here, which would be positive in this case. It could be negative or it could be neutral. Well, not neutral, but no correlation. By eye, draw a line of best fit. Now this still means draw a line of best fit. You still use a ruler. Okay, I'm not going to use a ruler, but that's only because I'm doing it on here. If I try and draw a straight line, I think I've started to master it now. You need to try and get roughly the trend of the data. There we go, something like that. Maybe there. And I'm just going to move it to there. Roughly the trend of the data, roughly the same amount of points each side of the line. Now, I'm quite happy with that. I've got 1 point here, 2 points here, 1, 2 here, and then 1 on the line. I think that generically follows the trend of the data. I'd be quite happy if I saw that one drawn on a paper. Common misconception, this thing here is fine like that. It doesn't need to go through the origin. The origin where the axes meet, it's fine. You can hit the axes. And finally, it says, using your line of best fit, estimate the average percentage of cloud cover on a day with 0.6% rainfall. So what I'm going to do for that bit there, so 0.6 there. I'm looking for 0.6 on my graph. Here it is, 0.6. I would draw a line. Now your line will be better than mine, no doubt. Let me try and zoom in a little bit so I can make it a bit easier. Draw a line coming across here, again using your ruler, hits the line, comes down there, which is one little square on, so that would tell me that it is 62% cloud cover. Okay, area for a triangle, no matter what the area of the triangle, you always use the same formula, which is area equals base times height, all divided by 2. You may see it as area equals a half base times height. Okay, it's whichever one you're familiar with. I prefer this one because I think it's a bit more obvious, a bit easier to calculate with, but it's whatever you're used to. Okay, so you're told that EF, so E to F, so that's this entire line here, is 11 centimeters, and you're told that DX, so that is this line here, is 7 centimeters. And that's great news, because when I'm talking about the height of a triangle, it's got to be at right angles. Think about when you're measuring your own height. How do you stand up to be measured? Say this was a wall. Would you go up and lean up against the wall like that? Definitely not. You'd be wanting to stand up nice and straight, wouldn't you? And that's what a height is. You need to be standing up nice and straight. So in terms of my base, obvious, that's the base. In terms of my heights, again, obvious because of that right angle. So my formula is going to be 7 times by 11 divided by 2 to work out the area. And my area is going to be, well, 7 times 11 is 77. And then I need to find half of that, okay? Now, probably the best way without a calculator for me would be to split it into 70 and 7. Half of 70 is 35. Half of the 7 is 3.5. So my area is going to be equal to 38.5 centimetres squared. It said state appropriate units for your answer, so I've not missed out on that important mark there. Draw an enlargement of the shape below using scale factor 2. Scale factor 2 just means make everything twice as big. It also says use A as a centre of enlargement. And people draw this wrong. They look at that centre and they say, oh, make that twice as big from the centre. So it's going to look something like this. Wrong. That's not how you do it. What you do, pick the nearest corner. So I'm going to pick this corner here. How do I get there? From the centre. So here's my centre. I go across 2. Reset. Back to the centre. Don't go across 2. Make everything twice as big. So instead of going across 2, I'm going to go across 1, 2, 3, and then 4 by here. Okay? Absolutely fine if you want to carry on doing it that way for the entire question. You don't have to. There's a quicker way that I think works a bit nicer. But if you want to say, right, how do I get to this corner here? I go down 1, 2, 3, 4, and then across 1, 2. Reset, I'm going down 8 and across 4. Fine, it's not a problem. The other way we could do it is that I can measure how long this line is here, which is 4 big, and then say, well, the enlargement is going to be twice as big, so I'm now going to draw that 8. Okay, so if I zoom out a little bit, and I'll try and draw in the 8 straight down. Okay, so there's my 8 straight down. Next, I'm going to look at this line here. Now, as a rule, we tend not to like the slanted ones. Ideally, you only want to be doing this for straight lines that go across the squares. But this is fine because it is a true diagonal that goes through the corner of one square. So instead of going through the corner of 2 squares, I now need to go twice as big and go through the corner of 4 squares. So 1, 2, 3, 4. So I'm going to draw that point in here already. Now, it would literally just be a case of my ruler that I just join up to that point there and join up to that point there. Okay, drawing a line, drawing a reflection in the line x equals 1. So x equals 1 here. So x equals 1. Right, do what it says on the tin. X equals 1. So x, here's the x-axis. Where's it equal to 1? Here. You draw a line that goes through this point, okay? There and there. Okay? Now, the reason why this works is because if you look at any point on this line, any point on it at all, the x value is always 1. The y value is changing constantly. Look, y is 1, now y is 2, y is 3. But x is always 1, so it's equal to 1. But it's confusing because it's parallel, obviously, to the y-axis. That's why some people get it wrong. And I'm going to label it. So x equals 1. Okay? So I like to just think of reflections as looking back into themselves. So this point here is 1 away from the line. So when I draw its reflection, it would be 1 away from the line, but in the opposite direction. This point here is 1, 2, 3 away from the line, so it needs to be 1, 2, 3 away here. So by there, and then that last point there, well, obviously it's just straight above, isn't it? So I could just draw it straight above here, but for point of arguing, 1, 2, 3 away from the line. So 1, 2, 3 away from the line here, and then it's literally just a case of joining it up with your ruler. Okay, you've got your ruler. You can be a bit easier for you than it is for me. There. Okay. For part B, again, this will be easier for you because you've got tracing paper. You'll need tracing paper. I'm going to have to try and do it, working out off the top of my head, which is never easy with rotations. So, 2, 1. That means go across the corridor and up the stairs. Some people get confused. Remember, it's going to be in alphabetical order, so X, then Y. Okay, so I'm going across to 2 on the X-axis and then up to 1 on the Y-axis. So, you've got to plot that point. There'll be a mark for plotting that point. Now, when you plot it, can you draw a crosshair through there and a crosshair through there? Because that'll split it into 90, 180, 270, 360 for you, as we've already discussed previously. You are now putting your tracing paper over the sheet, and you are going to trace, obviously, the shape, but you're also going to trace the crosshair as well. Putting your pencil now on the point, you should be holding the tracing paper and doing 1/4 turn so that these crosshairs cross over once. Okay? Now, by my reckoning, if you've done that correctly, because we're going 90 degrees anti-clockwise, so we're turning this way, I think it should be... about here, roughly one of the corners. Okay, so I'll try and draw in the rest of them, but obviously I'll need your feedback whether that's right or wrong. Okay, so I think it should look something like that, and then obviously I'd go and draw in the lines there. Okay, and so this question here says, Mr. Roberts is travelling to Hong Kong on business. There's a time difference between the UK and Hong Kong. When the time is 6 a.m. in the UK, I'm just going to write this information down. So UK 6 a.m, Hong Kong it is 2 p.m. So what is the time difference? Well, there's a couple of different ways I could do it. I could say how many hours until I get to 12 p.m. and say, well, add 6 and then add 2, so it's a total difference of 8 hours. That's one way of doing it. The other way of doing it, probably easier than that way with this question, is to say, well, I'm asked when it is 10 a.m. So when it is 10 a.m, it is 4 hours further on in the UK, so I've literally just got to add 4 to Hong Kong, whichever way works for you. Okay, so that would be 6 p.m. in this case. So the answer, 6 p.m. Okay, the next thing says, Mrs. Roberts stays in the UK and has given her husband her time schedule shown below. So 6 a.m, get up, walk the dog, breakfast, blah, 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 blah. Okay. Mr. Roberts will be in meetings most of the day in Hong Kong from 8 a.m. until 11 a.m. He'll then from 12 noon to 6 p.m. So that's when he's in meetings. So I can see there that I sort of know what the question's asking, but I know that he's free from 11 a.m. to 12 p.m. He's got an hour off then. And then he is also free. It says he plans to telephone his wife at a convenient time during the day. Which time period should he give his wife a phone call? Well, he's free after his meetings finish at 6 p.m. as well. So 6 p.m. onwards, that's when Mr. Roberts is free. Okay, so all we have to do now is try and match up in the UK, but these are all in Hong Kong as well. These are all Hong Kong times. So I have to try and match up where that works nicely for his wife to take the phone call. Now this is when that 8 hours that I worked out before actually works out quite nicely now. So I know that if I take off 8 hours, I'll find out when she's free. So if I'm looking at this first time here, 11 a.m. to 12 p.m, if I rang up Mrs. Roberts, it would be in the UK, it would be 11 take away 8, so it would be between 3 a.m. to 4 a.m. So she's obviously going to be asleep at that time, so that's no good. Okay, so the next time that he can possibly ring is 6 p.m. So if we look at 6 p.m. and we take away 8, now this is where you've got to be careful. It looks like there's going to be -2, but obviously I should be writing times in here. So this was a.m., this is p.m. Take away 8 hours. That shouldn't be a.m., should it? It should be take away 8 hours. Would take me to 10 a.m. Now all I need to do now is try and work out a time that fits in with her. She's arriving at work. She's in work at 10, so you can't call then. Finish work, set off to go home. 12:30 p.m. arrive home for lunch. Now that's fine. She's at home, and then she's at home until 12 p.m. Sorry, 12 p.m. 2 p.m. So she is free from 12:30 p.m. to 2 p.m. UK time. So I just need to add on 8 hours for Hong Kong time. So that would be 8:30 p.m. up to 10 p.m. Hong Kong time. Okay, the next part of this question is asking you to work out what's a better deal. So it says Mr. Roberts is going to be in Hong Kong for 4 nighs. He finds 2 suitable hotels. So we've got this one here, which is £80 per person per night. And this one here, which is more expensive, but it says stay 3 nights and your 4th night is free. So if he was to stay in the Hotel Gelton, so I'll say Hotel Gelton, he would pay £80 each night, so £80 times 4. So quick way of doing that, 8 times 4 is 32. And then there is a 0 left here, so I'm sticking the 0 there. So it's £320. And then the Hotel Bear, so I'll do that by here. Now, bear in mind it's got a special offer. It's saying 3 nights and your 4th night is free. So he only has to pay for 3 of the nights, because the 4th one is free. So it's 107 times by 3. So you can see I'm setting that out slightly differently, because it's maybe not quite so easy to work out. 7 times 3 is 21. Carry the 2. 0 times 3 is nothing. Add the 2 is 2. And then 1 times 3 is 3. So it's 321. Okay? Now, in terms of which one is a better deal, this one's obviously cheaper. But this one, for £1 more, you get dinner, bed and breakfast for £107, whereas this one was just bed and breakfast. It's really up to you. It's your hotel, because, and then you just have to give a valid reason. So it's whichever one you think is better. Personally, for me, I would say go to that one there. It's cheaper, and then go out and see some of the culture in Hong Kong. It'd be wicked, rather than having to stay in Hotel Bear and stay in the same hotel for the next 4 nights. But it's up to you. It's your choice. Okay, the next one, exchange rates. How much? So currency exchange rate is $15 as a pound when you go on holiday. It's $17 to a pound when you come back from holiday. How much of the £400 did Mr. Roberts spend while in Hong Kong? Give your answer in dollars. Now be careful you choose the right one here. We're going on holiday, so we're interested in this one here. Okay, so I'll write out by here £1 equals $15, and to get there we times by 15, and to come back we divide by 15. Now we are going very much in the pattern that's £400, so we're times it by 15. So 400 times by 15, and I'm going to use the same trick I used above, where I did 8 times 4. I'm going to do 4 times 15, so double it, 30, double it again, is 60, and then I've got 1, 2, 2 zeros there, 1, 2. So he gets $6,000, okay? But these are Hong Kong dollars, not American dollars, so things will be a bit more expensive over there. It says, on return from the business trip, he exchanges £1,500. Will he receive more or less than £100. Now this is when the other bit of the question comes in about it being a case of different exchange rate. So when he's coming back from holiday, he gets £1 is equal to $17. Okay. In fact, actually, I'll remove that bit there so I can put in the arrows here. So when I'm coming back from holiday, I'm dividing by 17. Now he's got 1,500, and we're dividing that by 17. And quite clearly, if I had 1,500 I divided by 15, it would be 100. But the fact that I'm dividing by more means I will get less dollars. Okay, bit of a sneaky one, that one. It requires quite a bit of deep thinking. But think about it logically. If I've got 1,500, I'm dividing it by more than 15. When I know 15 will get me 100, then if I'm divided by more things, then surely I'm going to get less overall. Okay, so my answer is less, as dividing 17 will share it thinner, I'm going to say, than dividing by 15. Okay, but that will literally be 1 mark. If you don't get it, it's not the end of the world. Okay. Okay, and so looking at the first bit of the question, I can quite clearly see the pattern. This is just going up in odd numbers. And then this is just going up in even numbers. But this is a waste of time. I don't need to be doing this because my question is this one here. So this must be 105, this must be 101, 99, 97. That means this must be 98, 100, 102, 104, and 106. For the next part of the question, it says 5 numbers. Okay, so 5 numbers next to each other on one side of the road total 65. What are the numbers of the 5 houses? Now, this is where algebra would work really, really nicely, but it's quite a complicated bit of algebra. It's not the most obvious in the world to do, so let me just show you what I do, but you can get there through trial improvements as well. Okay, now I would say that the first house number, I don't know what it is, so I'm going to use a bit of algebra. I'm going to say it's x, okay? So I'd write down x. And then, because they total 65, that means I'm adding it. Now, the number next to it, again, I don't know what that is, but in comparison to the last one, so if we look at this number here, for instance, then it was that number added 2. So this would be x add 2. Okay? Then the next one would be x add 4, and then x add 6, and then x add 8. That's how I do it personally. So 1, 2, 3, 4, 5 houses. And then they just keep on going up in 2. So, for instance, 98 add 2 is 100, 98 add 4 is 102, 98 add 6 is 104, 98 add 8 is 106. Okay, now that comes to 65. So then, how many x's have I got? 1, 2, 3, 4, 5. So I've got 5 x's plus, and then we just need to add these guys up. So 8, I'm going to look for number bonds. So 8 add 2 is 20. 8 add 2 is 10, 6 add 4 is 10, and then 10 add 10 is 20. So that comes to 65 still. I'm then going to solve the equation. So I'm taking away 20 from each side. So I get 5x equals 45. And then I'm going to divide both sides by 5. So I get x equals 9. So that meant that my first house, see if I can move these very quickly, there we go. So my first house was number 9. That means my next house was number 11 and 13 and 15 and 17. Okay, and then the last question says the product. So product just means multiply. The product of the numbers on 2 houses which are directly opposite each other, so that's obviously important, is 380. What are the numbers of these 2 houses? So what numbers obviously times to 380? Well, there's not many that obviously stick into my head. So I'd obviously think of 1 and itself, maybe 2 and 190. And for me, really there's not a huge amount else that's really, really obvious. However, I can spot maybe that 20 times 19 would make it, and that is my combination. Okay, again, these 2 marks you'll probably either get them or you won't, but just try and show some sort of knowledge that you know that 380 means product is times, and you're showing that you're trying to get numbers to times together to make 380. Okay, and so this dog is tethered to this building, and it can roam about on its leash. So it can come all the way over here, absolutely no problem. It can come all the way to here, but something's going to happen by here. Its lead that it is on here is going to get snagged on the building, and it's going to have a much shorter tether there. Okay, now you need a compass to this. Okay, so your compass, you would have the point on here, and you put your pencil on D by here, and you draw an arc coming around something like this. Okay, something like that. You would also carry on your arc to the corner of the building here. Okay, so that is just one foul swoop with your compass like that. Okay, so I've just made that arc. Okay, obviously mine's not that good, yours will be better. Okay, now what's going to happen here is that the dog's leash is going to get caught on the corner of the building, so that means all of a sudden that he's got less leash to play with round this corner. Okay, so you now move your compass point from being here to by here, and then you are going to draw an arc that is going to be matching your pencil up to the end of the line. It's going to come in something like that. Okay, making R the subject of the formula means I want to get R on its own. So the first thing I'm going to do is times both sides by 3, or move the 3 across to get 3v equals 4 pi r cubed. The next thing I'm going to do is, starting to get R on its own, is get rid of the 4 and the pi. So I'm going to divide both sides by 4 pi. So I'm going to get 3v over 4 pi is equal to r cubed. And then the very final bit I'm going to do is take the cube root of the other side. Okay, so we're going to get 3v over 4 pi is equal to r. Okay, so basically what I've done is taken the cube root of each side, and what that does is that will cancel that guy there and there. Okay, cube root, sorry. Next one's probably easier. Again, these are both pretty tricky. You know, we're looking at firm B grade task here. This isn't the easy stuff. To make D the subject of the formula means get D on its own. So I've got to get D's on both sides. And can you see here, I've got a D and an E there and a D there. So I've got to get the D's on one side. So I'm going to take 2D off each side. That's going to give me DE minus C. So still all of this line here, but then also minus 2D is equal to G. Okay. The next thing I'm going to do is get rid of this C from this side, so I'm going to plus C to each side. So I'm going to get DE minus 2D is equal to G plus C. Okay. Now we're starting to get there. I've got to try and get D on its own completely now. So the way I do that is factorizing. So if I pull D out as a factor, I will get E minus 2 there from our factorizing skills is equal to G plus C. And then I would divide both sides by this E minus 2, which is going to give me D equals G plus C all over E minus 2. Okay, and to finish off, some probability trees. First of all, I've already seen this one's a quarter. That means I know this one should be 3/4. Next, reading the question, I'm told that the probability that Dylan has a coffee is 2 over 5. So having a coffee, 2 over 5, that means this must be 3 over 5. And I can go and fill those in both. Okay? Now the next question says, calculate the probability that he has a dessert or a coffee but not both. Now I'm a fan of actually working out what these are. You multiply between the branches. Pretend this is a big time sign here and here. So we times in between the branches, times in between the branches, like so. Okay? Just to make it a bit neater, I'm not going to do that. And 1/4 times by 2/5, that would be 1 times 2 on the top, which would be 2. And then it would be 4 times 5 on the bottom, which is 20. Next one is going to be 1 times 3, which is 3. And then 4 times 5, which is 20. So just so I make it really nice and obvious what I'm doing, 1 times 2 gave me the 2 there, 4 times 5 gave me the 20 there, 1 times the 3 gave me the 3 there, 4 times 5 gave me the 20 there. So 3 times 2 here is going to give me 6 over 20. And then finally it's going to give me 9 over 20. And a very quick easy check to see if I'm right. 2 add 3 is 5, add 6 is 11, add 9 is 20. That gives me 20 out of 20, which is a whole, so that's looking good. Final bit. I'm looking for the option where he has a dessert or a coffee but not both. So I'm interested in the ones I'm going to star. So here he has a dessert, and then he has a coffee. But I didn't want both, so no, I don't want that one. Here, he has a dessert, and then he does not have a coffee, so that's good, that fits the criteria. And then here, he does not have a dessert, and then he has a coffee, so yeah, that's fine, he has one of them. And then here, he doesn't have a dessert, and he doesn't have a coffee, so he doesn't have either. So these are my two options that I'm interested in. So that's 3 out of 20, add 6 out of 20, which is 9 out of 20.